Welcome to Subaru Ecu Flash Training Part 14. In this video, we're going to be taking a look at how to work with our speed density based tuning with a Carberry ROM, doing closed loop style fuel tuning. So we're going to be looking at how to work with our short and long term fuel trims and learning how to calibrate working with our volumetric efficiency fuel table, as well as programming all of our injector data and any other tips and tricks along the way to make sure you can successfully calibrate your vehicle using a speed density based ROM file. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our speed density style tuning utilizing a Carberry ROM. More specifically, we're going to be focusing on doing the closed loop style tuning for idle and part throttle driving. We're going to have a separate tutorial. In fact, the next tutorial, we're going to be taking a look at doing the full throttle open loop style tuning and speed density. What we're going to find here is that we have a lot of flexibility in the calibration and tuning process compared to the mass airflow. We can go about things in a variety of different manners. I'm going to go through and show you what to look for and how to make the calibration changes correctly in speed density style tuning so that when you're estimating your airflow, everything is going to be going in and working properly within the Subaru ECU. And I do want to mention that speed density tuning is not an option normally in the Subaru ECU. So if you're looking at a Subaru base ROM, you'll find that they're based on the mass airflow sensor. Up to this point, we've covered how to work with the mass airflow sensor in the calibration process relatively extensively, so you should understand how that's going to work. Speed density is going to vary. We're not looking and using the mass airflow sensor any longer. We're actually working with the MAP pressure sensor. That's going to be the manifold air pressure sensor. That's going to be used for the load inputs into our fuel and spark timing calculations, among the many other things within a Carberry speed density based ROM. We're going to break down and take a look at some of the key things we need to know in speed density tuning utilizing the Carberry ROM in this video. We're going to be doing some live demonstration of the calibration process for this closed loop style tuning, and then we're going to be working with our Megalog viewer and determining and analyzing that data in order to make our changes most efficiently and accurately within our calibration files. So we're going to go through the whole process, what to log, what to look for, and how to make the changes. It should be very clear of how to accomplish speed density tuning for idle and part throttle when you're done with this training tutorial. All right, so the first thing I want to cover here are the basics of how speed density works, because this can be a little bit confusing. We know the mass airflow sensor is going to be actually directly measuring the airflow or the volume of air as it's entering the engine. And we know we have an air temp sensor circuit and a baropressure sensor that's going to be determining the air density that's entering the engine, and to determine the air mass, it's volume times density. So knowing the MAF curve and knowing our air temp and baro information, we can determine air mass. We know that fuel mass is equal to air mass divided by target air fuel. We've covered that in previous training tutorials. The air mass is going to be something that we would measure in the terms of a mass airflow car. We'll find that the target air fuel is something we specify in the open loop target air fuel table. If we're in closed loop, it's going to be just going and trying to target stoichiometric, which is 14.7 to 1. And then we'll find if we know the air mass, we know the target air fuel, we would know then what the fuel mass should be. Now we figure out what the injector pulse width should be actually pulsing the injector at to deliver the fuel mass based on the injector scalar or the flow rate size of the injector, our latency data, a minimum pulse width, and a short pulse width adder tables. Combine all those together, then we get a final corrected injector pulse width, which should match what we're trying to go in and request for a fuel mass. Everything should line up within our airflow and our fuel modeling. That's going to be the same kind of concept that we have here in speed density, but we're not measuring the amount of airflow that's entering the engine. We're actually going to be estimating the airflow, and that's where a volumetric efficiency speed density table comes into play. That is the key differences between speed density and mass airflow, where the speed density is going to be where we estimate airflow, and then the mass airflow is where we directly measure it. So it's up to us within speed density in the calibration process to make sure that we're representing the airflow coming into the engine in a proper manner, that we're not overestimating or underestimating what the airflow is going to be. Now, we have a lot of flexibility in the tuning, especially on the fuel side of things, when we're dealing with a speed density calibration, as we're going to demonstrate here in this video. We can go after the injector data. We know we were starting to look at that and how to calibrate that within the mass airflow specific training tutorial, or we can go after the actual fuel table. We have a lot more data points to hit. We have a lot more resolution in the table to adjust the fuel for fine delivery and ultimately to just get the injector pulse with to deliver the fuel that we're expecting. But there are some rules and just some things that we need to know in order to make sure that we're changing the correct things within our calibration file, whether we want to go after the injector data, the latency specifically to adjust some things, or whether we want to go after the actual volumetric efficiency table to make our updates and our calibration changes. So again, it's going to be very clear once we start to data log and once we start to take a look at this information here, we're going to know exactly what to do. But let's go in here and start to jump into the file that I have open. Now this is a speed density Carberry calibration file that I've prepped in anticipation for filming this training tutorial video. You're able to find the same kind of file if you go to File Open and we go into our Subaru Course Packet sample ROM files. We have these two C42 Blue Base TD04. Either of these files here are going to be speed density based. These files here are specifically prepped for a stock Subaru that has stock map sensor working with the mass airflow housing, and it has the air temp sensor circuit. We haven't replaced that with an aftermarket air temp sensor. So this is going to be a good starting point if you're relatively mild WRX, you have mild bolt-on mods, even a smallish upgraded turbo and stock injectors. If you're dealing with a larger build, so you're going to be dealing with something that's big injectors, big turbo, you'd want to go and start off with a Carberry V302 Map SD. So these two files here are essentially the same. This is more tweaked stock injectors utilizing a stock MAF housing with the air temp sensor circuit. This is going to be more appropriate to begin with. This is for bigger injectors and bigger turbos. So what I have here is this specific ROM that I just went in and made changes based on the injector size and some other details, as we'll go over a little bit later in the training tutorial. But if you want to go and look at a speed density sample file here, if you're following along, you'll either grab your Carberry Map SD or this particular, the C42 Blue Base TD04. That's going to be for stock size injectors. The pink is going to be for STI pink injectors. It's going to be the difference between these two, so depending on what you have and what you're working with. But these are a speed density Carberry based ROM. They are not a load based. The load based is utilizing the stock grams per rev load into something like our spark timing tables. When we're dealing with a speed density ROM, we're running map pressure as our load input for the spark timing tables. So we can be off in the way we're estimating the airflow in the volumetric efficiency table, which won't affect our spark timing calculations because everything is centered around the map pressure readings, the map pressure sensor readings, which have no influence or scaling based on anything with the mass airflow sensor. So it's a little bit easier to kind of tune this out. We don't have to worry about a lot of the restrictions and limitations that we have with a mass airflow sensor. But again, we still want to follow the general guidelines as what I'm going to show here in the training tutorial. So you're going to make sure that everything is falling in line as it should when you're going in and doing your fuel and spark timing tuning. But just to point that out, that's where these files are coming from here. So the file that I'm working with here, again, that's open, speed density based ROM. We know where to find those particular files if you want to go and follow along. Now, in our current ROM metadata here, let's go.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.